I appreciate that. Yeah. I was already nervous and a little bit, I felt a little guilty about standing between you and the cocktail hour because I kind of want to participate in the cocktail hour, but whatever. All right, thanks for coming to my talk. Thanks RedisConf for having me. I'm here to tell the story about the real estate brokerage and the in-memory database. A little bit about me. I started at Redfin 10 years ago, so I'm the opposite of most career tracks in the Bay Area. I actually started in Seattle, which probably explains it a little bit. If you're not from Seattle or the Bay Area, you might not be familiar with Redfin. Redfin is the next generation real estate brokerage. We combine full service agents with modern technology to redefine real estate in the consumer's favor. That's a lot of words. I literally lifted it from our PR department marketing materials. But basically what we do is we take agents, licensed real estate agents, and engineers, and we build technology, put them together, and create happy customers. I've done a lot of things over my tenure with Redfin. Most recently I've been working on developer productivity stuff, but not that long ago, I was one of the folks who sort of urged our engineering team to adopt Redis internally. I am an actual Redis user. I'm not a paid actor. If I do a good job in this presentation though, you all at the end will be questioning whether or not they paid me to be here. I'll talk a little bit about the goals for this talk. It's a little different in scope than some of the other talks that have been going on today. My goal is to get you pumped. This would have been a great talk, honestly, probably at the beginning of yesterday. But anyway, my goal is to get you pumped, or to have this aha or a what if moment, to get you excited about Redis and all the things that it can do for you and your organization. The general outline of the talk will be a little bit about the past, how we started using Redis at Redfin. I'm going to mix those two words up a lot, by the way. I'll talk a little bit about how we're using Redis right now. And then I'm going to talk a little bit about the future with a question mark. Like maybe it's the future, maybe it's not, but sort of the things that we could do with Redis that would make sort of our engineering team's life easier or our customers' life better. All good stories start in a faraway place a long time ago in the past. I'm only taking you back to 2015 though. 2015, Redfin had no cache, no shared cache at all. We had in-process caches, but that was it. And this is not a very typical architecture, I think. You won't hear a lot of companies write blog posts about why this is a good thing. And honestly, we wouldn't write blog posts about why it's a good thing either. But we made it that far, the 8 years at the time that I'd worked at Redfin, writing very, very powerful database machines, SQL database, PostgreSQL. We have lots of cores, lots of RAM, and very fast Fusion IO drives. I'll talk in a second, but we host our databases in-house and our web apps, so we're co-located. We're not in AWS, and part of the reason is these massive database machines. These get really expensive if you try to provision IOPS and get enough read throughput to match what these Fusion IO drives give you. So it's 2015, we have these massive databases, life's pretty good most of the time. We're based in Seattle though, we know it rains. Sometimes this relationship isn't perfect. We have site instability and we're trying to figure out what to do about it. One of the things we're exploring is a cache. We need a cache. We have twice yearly hackathons for sort of team bonding purposes, primarily. We also get to explore new features that our product managers normally wouldn't let us build. We evaluated both Redis and Memcached. This isn't the Memcached conference though, so I'll talk mostly about Redis. When we evaluated it, we found all of the things that you see in the online documentation to be true. It's fast, it's lightweight, it has clients in many different libraries. The ones that are important to us are Java, JavaScript, and Python. There's a strong community. You can sort of feel that here today, yesterday, lots of people that are really excited about it. It also had optional persistence, which folks argued back and forth with me, or I should say we argued as a group about whether or not that's something you really want. But if you're looking to the future, and it's something that one of your two cache options has and the other one doesn't, maybe you want to consider that. Redis also introduced clustering right around this time. This is a cluster nodes, the output of a cluster nodes command. This is something that we were really interested in too. We didn't want to have to do client-side sharding ourselves, and Redis provides the tools for client authors to help you with that. This is a Google Trends graph. I intentionally didn't label it. Which one's Redis? It's not the red one. So up and to the right is what we like to see, right? Redis has been on a trajectory. Interest is growing over time. It seemed like a safe bet in the sense that it's getting more and more popular. More and more people are using it. There would be more community interest around it. It also has a lot of features. Like that's, again, if you're evaluating a technology and one of them does one thing well and one of them does that thing well and a bunch of other things, which decision should you make? So in 2016, myself and one of the operations guys finally convinced the rest of the organization. We deployed it, and our relationship with Redis was sort of officially kicked off in production. And it was the feeling around the office was sort of like that same feeling when you buy a home and it has a sweet pool and you're really excited and your kid's really happy. It was sort of like that. So that was the past. Let's talk about what things are like today. I'll talk a little bit about our setup. So we have about a 200 gigabyte cluster. It's not the biggest cluster that folks have talked about today. We have 13 shards. That might actually be one of the biggest that has come up and been discussed today. It's like 15 gigabytes per shard or something like that. One of the reasons that we have so many shards in such a small cluster, small relatively speaking, is that we're running it in spare RAM on our web servers. This is how I badgered the ops team into doing this. Hey guys, we've got gigabytes of RAM free, the application's not taking it, Redis doesn't take any CPU, like, you wanna do something for me? You wanna do me a favor, right? I already mentioned that we're running on our hardware primarily. WalkScore, which is a Redfin subsidiary, does a little bit of stuff in Elasticache, and I'll talk about how they use Redis as well. For the client, we do most of our talking to Redis from Redis, which is the Java client. And we built a wrapper around it so that we get stats for free. One of the things that people really want to know is whether or not their feature has a high hit rate or how many errors are being served to customers when they try to talk to the cluster. So we built a wrapper around it, the platforms team, and we get these stats for free. And we sort of abused Java's default methods in interfaces, Java 8, to get a convenient domain-specific language for reacting to errors and misses differently and repopulating the cache when a value's not there. This is a throughput graph. It's kind of hard to see the axes. That's okay. I've got an arrow. We peak around 2,500 operations per second. Again, I said across 13 shards, so about 190 operations per second per shard. That's nothing. I'm going to show you in a second why I mean that's nothing. We're not stressing Redis at all. I'm not afraid to admit it either. This graph is median, mean, and upper 95 from Grafana that comes from that wrapper around Redis. The important line here is this one. You probably can't even really see it from where you're sitting. 0 milliseconds median. How do you get 0 milliseconds? It's quite impressive. This is also 0 milliseconds as measured from the client. This isn't in Redis, right? So it's kind of cheating, not gonna lie. Integer math rounds anything under 1 down to 0, and our intra-data center ping is less than a millisecond. So we get, Redis here is effectively free in our architecture. It costs us nothing. We are mostly caching with Redis right now. So I'm gonna take you on a little tour here. We're a real estate brokerage. You can look for listings on our website. You might search for San Francisco. There'll be a list of homes on the side. You might click the top one and you'll see a page like this. This is our listing details page. If you scroll down, you'll come to this section. This data isn't something that we have in our database. We go to a third party for this. We actually go to WalkScore, so they're not really a third party, but they're in AWS in Virginia, and we are not. So we cache this, like you do. Third party data doesn't change, cache it. when we started caching it, the timing for that endpoint dropped considerably to like 20 milliseconds. And this is still actually like backed by Java, so some of that's JVM overhead. This is a huge performance improvement for us. It's noticeable, and we did this to several endpoints and got similar results. We cache third-party API responses like that one. We cache random database queries like you do. Nothing really exciting there. In addition to caching, we're doing rate limiting. And I felt like when I was looking at this that rate limiting is something that everybody's doing, but I actually didn't hear it mentioned much at all in the last couple days. They did mention it in one of the keynotes today, which was a little disappointing. I thought I was going to be like the only person to talk about it, but rate limiting is pretty cool. So I mentioned WalkScore, Redfin subsidiary. They provide APIs to folks who want to use their data. They also consume APIs of other companies, like potentially Google. Other APIs have rate restrictions. You can't call them too much, or they charge you more money, or they just don't return fast, or whatever, Google. So we rate limit on the client side, on our end, to make sure that we don't exceed what we've paid for, the throughput that we paid for. Rate limiting in Redis is pretty straightforward at its core. You have a key that corresponds to a time bucket, and then you increment the value in that time bucket, and if it's over a certain value, you just return false and say no from the client. Even more cool about Redis than just that is that if you do all this in a Lua script, where you increment the key, you do the check, you set an expires on the key so that it doesn't like persist forever, and you return true or false depending on whether or not the action is allowed. This all executes atomically. And this has come up multiple times today, but this is really cool. Redis is single-threaded, so all of these operations execute atomically. And the keys expire automatically. This is something that, like, coming from a SQL database world where I spent most of my time there, this is pretty exciting to me. This is something I don't have to clean up, right? That's awesome. And I said too simple on the slide because the rate limiting situation, approach that I just described is maybe good enough for some cases, but it allows bursty behavior around the boundaries of the buckets, right? So at the end of your 1 second interval, potentially, if you get 10 requests that come in and then 10 requests at the beginning of the next interval, you've let 20 requests through within the same 1 second time period. So it's more complicated than that. There's a Redis module online that implements a sliding window, and there are several other approaches that various companies have tried and documented. So you can find all sorts of this stuff elsewhere. You don't need to hear it from me. I'm not embarrassed to say that this was one of my aha moments for Redis, where it finally clicked that this can be something more than a cache. It's solving real problems with like rate limiting, for instance. Expiring keys means I don't have to do it manually. And the whole idea of executing multiple commands as a single unit is like, it just feels different and better somehow than executing commands in a transaction in a SQL database. I like it. It makes me happy. So I talked about caching. I talked about rate limiting. That's what we're doing today. Honestly, if this was the end of the talk, I wouldn't fault you for being a little bored. But what can we do with Redis beyond just like simple caching and rate limiting sorts of situations? Redis has been described as a Swiss Army knife. The stock photo that I was able to get that we have license to is actually a suite of tools, so I'm going to call it a suite of tools. But there's that saying that like to a person with a hammer, everything looks like a nail. There's a hammer in this suite of tools. And it's got Redis written all over it. So I've got Redis. I said if we were only caching, that would be boring. That's not quite true because you can cache all sorts of things. One thing that I'm pretty excited about is at some point I'm going to have time to start caching some of the data that we use for authentication. Right now we make a SQL query to do some auth and fetch related data on every request. And we're not like Facebook or Google scale, but like this adds up after a while. And if those requests get slower, everything gets slower. Our whole site gets slower. Recently viewed listings. If you're a customer on our site, we might want to display, hey, these are the last 3 listings that you clicked through, so you can find them again easily. seems like a perfect use case for something in Redis. We don't need to store it long term, but storing it in memory makes sense. User filter settings, maybe on the map where you're saying I want homes in the 300 to 500K range. You could store them in a cookie or something, or you could store them in the database. But Redis seems like a perfect place that those could live. Our analytics team has actually kind of been bugging the engineering team about this. So we are all hosted, but our analytics team does all of their work in AWS. And we basically have an API there that is frequently just Dynamo tables, where they put data that we're supposed to fetch, and then we fetch it. This is kind of expensive. Dynamo's not super cheap. And so they've been bugging us and saying, hey, if you guys implement an in-house cache for this, it'll save us thousands of dollars a month. So something to consider if you have a split sort of on-premise and cloud operation. So back to the map. The map is a focal point of our site, so we're going to talk about it again. There's all sorts of caching opportunities on this. One that we're utilizing right now is if you search for San Francisco, we can retrieve the results from the database, store it in Redis. We're actually doing this. I didn't talk about it at the beginning, but we're doing this already, and that's fine. It's super simple. There's a string key, San Francisco, and there's a list of property IDs or whatever. Cake. But there's sort of all or nothing eviction here, right? Like there's no granularity. If anything in that region changes, we've got to flush it. So we have to flush this fairly regularly, which sort of defeats the purpose of caching in a lot of cases. So one of the things that, this is another aha moment, one of the things that WalkScore does with their geodata is that they do lat-long bucketing. And if you work with geodata, this probably doesn't seem that exciting. To me, as someone who doesn't actually work with geodata day in and day out, this is pretty cool. Basically, you can divide up the globe into a grid and then cache data for individual squares, individual boxes. And then if the data in one of those boxes changes, you evict that one. But you don't have to evict anything else. And this allows you to horizontally scale, to like parallelize your queries across all of these different boxes, and it allows you to do other stuff too. Okay, more caching. We use React.js. I don't know how many of you are familiar with that, but the basic idea, the reason we got excited about React.js originally was that you can server render in something like Node, and then take the HTML and the data in the browser, run React on it again, react.render, and if the data is the same and the HTML is the same, React doesn't do any work to the DOM. It just attaches itself and you're off to the races. We have these home cards, that's what we call them, all over the site. We do work on the server in Node to render these home cards every time they come up. Why do we do that? It's just HTML and some data. This data doesn't change all the time. We can cache these. And then Node is single-threaded, it's CPU bound, or sorry, it's CPU gated in a lot of cases. And React render is synchronous, so it's blocking the process when this is happening server-side. We don't have to do any of that. We can fetch it from Redis, send it to the browser, and we're done. It's slightly more complicated than that, but this could save us a ton of CPU on those webheads that are doing the rendering. Okay, we're not applying the hammer to caching anymore. More rate limiting. I don't know how many of you, or I'm sorry, that's a poor introduction to that. To us at Redfin, SEO is a huge deal, search engine optimization. We get a ton of traffic from Google, less from Bing, where customers are typing in addresses in the search box and then trying to find their house or their friend's house or a house down the street that's for sale. So keeping these crawlers happy and busy is good for us. The more houses they can index, the better off we are. Sorry, the more details pages which correspond to houses that they can index, the better off we are. So what happens when one of these bots goes a little nuts? Well, so that yellow line in Bing bot, I'm not actually sure whether I'm supposed to say this number, but it doesn't seem that bad. That yellow line that Bing bot there is sitting right under is 100 requests a second. So BingBot, 100 requests a second, usually around 100 details pages per second. So when Google comes along and has that huge jump that the arrow is pointing to, it's getting to almost 200 requests a second, 200 of these details pages a second that they're rendering. And if Google's requesting those, customers are potentially affected in some cases as well, unless we complicate the architecture and split them up. But for right now, Google going nuts affects our customers, or can. So why not apply that rate limiting hammer to this? You get the user agent that comes in, you know it's BingBot. Bing is actually pretty good. They have a UI where you can control this. Google doesn't, or didn't the last time I checked. But what if we could say, hey, Googlebot, 100 requests a second, 120? Like 200 is a little much. Slow down. Text search and Typeahead is something, there were a couple talks about this yesterday, so I won't go into it in super detail, but we have search on our site. Many sites have search. There's an implementation in Redis in action. I cut the slide with the sorted sets. You can build this yourself, and honestly, when I was reading this online and I was reading these case studies about people building it themselves, I was like, I get it, I understand it, you had Redis, that's really cool that you can do this, but that's a lot of work. And there are other products that do this. But listening to the talks about Redis search yesterday, that module, that's really cool. It's really cool how fast it is, it's really cool how simple it is to use, and all of a sudden this seems like something like, if you've got Redis and you can install modules, like yeah, go for it. This is cool. So where are we at? We're at caching, we're at rate limiting, we're at full text search, okay. Redfin employs agents, and one thing that we've sort of tossed around now and again is this sort of like last minute economy, like I'm a customer, I call Uber or Lyft to take me wherever I'm going. We have this sort of problem too sometimes, where a customer is standing in front of a home and they're like, that home is for sale and I want to tour it. And I want to get in contact with an agent to do it. Redis can help here too. There's the geo commands and the sorted set of geo hashes, right? Where we could store active agents and their most recent location based on an iPhone app or whatever in a key associated with the neighborhood or the city. And when this customer's standing in front of this house and they say, hey, I want to talk to an agent, we can find the closest one super fast. Redis can help with that. We're gonna move a little bit away from user-facing features into the sort of middle of the stack now, which is where I live mostly. But so let's say you have a listing that comes on the market, and you need to import it into the database. You could do a thing where you write it into the database, and then there's a bunch of other processes off to the side that are polling and saying, hey, do I have anything to do yet? No. This is super naive. It's super contrived. I know. I apologize. But as soon as you try to horizontally scale these processes, if you have too many listings coming in to be able to have one process handle them, this doesn't make any sense anymore. Which process is responsible for the listing that was just imported with ID 37? Is it different than the one, like who's responsible for what? Do they need to communicate? It's super complicated. Redis can help here too. Redis can replace, or can be used instead of, maybe it doesn't replace, whatever. SQS or any of these message queuing products. So instead of writing to the database and polling, you put something in a queue, and then you could have consumers read it off and operate on that information. And this is built in natively, which I also find really cool, where you can issue a command that blocks until there's data in the list. Super cool. Real-time analytics. This is where I thought the talk before this was going, and then he talked about something that was also cool, but not this. So we write log data to disk, roughly, and then there's another process that takes it off disk and ships it in real time-ish to AWS, where we have like Elasticsearch, Kibana, Logstash, I forget which one's which, but we have products that sit on top of that allow us as developers to look at the data. Why do we write it to disk at all? We could write it into a Redis queue and then have a process that pulls it off there and sends it to AWS. this might look like just something that's more complicated than what I had there before for no reason, unless you also want to take some other action on that data as it's streaming through, right? Like maybe you have a consumer that is reading things off the queue as two consumers, one that's sending to AWS and one that is reading things off the queue to display in a dashboard. Why do you care about that? I mean, maybe there are obvious reasons, but one thing that I find really sort of potentially exciting is that you can do a reverse IP lookup on the client that caused the error. So a lot of the errors that occur in the browser, we end up shipping through a beacon to the server logs so that we can keep track of those as well. And occasionally, we'll get these clusters of errors where this file isn't loaded from the CDN or whatnot. And it'd be nice to be able to see that on a map in real time, like, oh, there's actually a cluster here, rather than waiting until 37 people that are within a few miles of Santa Clara email our customer service department and are like, hey, your site's not working, it looks kind of broken, what's going on? And we're like, oh yeah, Akamai's node there is having trouble, or the low-level network provider in the area is dropping packets. It'd be great to be able to see this visually before our customers tell us about it. You can also do aggregation, so like you could have dashboards, you could have tables, you could have whatever you want. And you could have informative displays. Another thing that excites me about Redis as a use case is tracking active users. So we can't answer the question right now of how many active users are there on the site. We can look at logs and say, oh yeah, at this time on this day yesterday, or a week ago, this is how many active users were on the site. But I can't tell you right now how many are on the site overall, or browsing just in San Francisco, or anything like that. This might be useful to an analytics team that wants to sort of keep track of this data as freshly as possible, if that's a word. So this looks pretty similar to the previous diagrams. We have these web browsers that users are requesting data from. Now we can write into a special kind of Redis value that's called a hyperlog log. And then you have a dashboard app that reads values out of it. So hyperlog log is a probabilistic cardinality algorithm. There are papers published. It goes, as this sort of mentioned this in one of the previous talks, there's a lot of math involved that I haven't really delved into. I'm sure it's really interesting, but not there yet. And this is implemented as a Redis data structure. You get this for free. All you have to do is extract the identifying information from a request. You add it to this hyperlog log value. Some magic happens, and then when you retrieve the value, you know within a very small percent error which or how many active users are associated with whatever region you're querying. That's pretty sweet. I should have practiced listing off all of these we've been through. We've been through caching, we've been through rate limiting, we've been through full text search. We talked about queuing, and now we've talked about hyperlog log. 5 things. 6 things. So real-time chat. We have this feature. This is only live in California if you've ever used Redfin outside of California right now, or it's only live right now in California. You won't see it if you're outside of California. But you can build this with Redis too. Redis supports PubSub. For chat, you can have a PubSub channel per active chat between a customer and an agent. When somebody sends a message, you publish it, and then on the other end, all the clients are notified, and you can display the message in the browser. I think multiple companies, too, at least, have talked about doing this at large scale. So you know Redis can do this for a wide variety of use cases. It's not just for chat, though. One thing that I'm super interested in is if I'm looking at the map page on redfin.com and a listing's imported through that process that I described earlier, Redfin knows what my safe searches are, and they know that the listing was just imported. I say we know that the listing was just imported. I should be able to push a notification to the browser of that user and say, hey, did you know that in Oakland, this house just came on the market that matches your results? And then you click on it, and you're amazed. Like I'm literally getting goosebumps up here right now. Like it's really exciting. The potential is really exciting. Distributed locks are another thing that Redis can be used for. This came up at work when we had multiple job servers that are supposed to schedule jobs, and sometimes they get scheduled at the wrong time and clobber another job that's running because they're on different servers. So what you need is something to gate these. Redis can do that. A naive approach might be something like, well, I want to secure a resource. I'll give that resource a name that's in a Redis key. I'll use set with not exists to try and set the value. If I succeeded in setting the value, the lock is mine. He totally told me I was going to hit that microphone too. If I set the value, it's mine. If I didn't set the value, then it's not mine, and I'll try again later. And that's it, right? Anybody in here ever read all of the threads about distributed locking in Redis? I am a little bit embarrassed to say that this naive implementation was sort of how I imagined it until I started looking into it, and then I was like, dang. You have to worry about things like, what if the client that just set that value is holding the lock and it dies, or it forgets to null out the value when it's done? Or what if the shard holding the key dies before replication has occurred to the slave? Like, all of a sudden this problem gets really complicated and you want to have had someone else solve it already. So there's a long discussion about it on redis.io. There's like multiple other discussions linked from there that also link to other discussions and have follow-up discussions. There's lots of client libraries that attempt to solve this problem. This is a rabbit hole that is kind of fun to go down if you have a couple hours. Not as interesting as I wanted it, or sorry, it is interesting. It is not as easy as I wanted it to be. And then last-ish, but not least, Redis modules. I am super excited about this. One of the things I feel like used to be a complaint about Redis was, well, you're sort of stuck using the data structures that you're given, and there's like a wide variety of things you can do with them, right? I just described a bunch of things that we might do with them at Redfin, but now if you can write C or Rust or apparently Python and several other languages, which I didn't know was happening, but they announced at the keynote or something earlier today, if you can write one of these modules, you can do basically whatever you want. I was actually really surprised, not really surprised, but it was really interesting to me to hear that there are at least two things that were announced here, the Redis search module and the high availability, the multi-master setup that do use Redis modules under the hood. So if you're feeling crafty, you can do a lot of cool things with these. You can write new commands to operate on Redis types. I put you could gzip values here before storing and ungzip on retrieval, but this actually, I wouldn't do this. You kind of want the gzip before you do the transfer. But maybe what you could do is you could encrypt them here so that when they get written to disk, they're not readable. When they're transferred across the wire to your replicas, they're not readable. I had this thought a few weeks ago that Redis modules would be a perfect place to try and to sort of play with SQLite in C. I watched a talk, it was really interesting. And I thought, hey, I bet I could build this. And I started working on it and then got distracted by something that was actually work related. And then Hacker News a couple weeks later, somebody's like, oh yeah, we built this and spent a lot of time on it and it's super fast and here's all of the tuning that we did on it. And I was like really glad that I didn't actually spend the time to try to work on all that. But it's really cool, you can do this. Linked hash map is my favorite Java data structure ever. It's basically a map, except you iterate over the keys in the order that they're added. You can build this in Redis. Twitter forked Redis a long time ago, years ago, whatever, to build a special hybrid list implementation that was more memory efficient for their use cases. You could theoretically do that now. I don't know that much about the details, but theoretically you could do that now without needing to fork Redis and then be stuck on Redis 2.4 or whatever for 10 years. You can build efficient search indexes. You can store JSON in Redis, you can store JSON in Redis, but you can also build modules like this in which you store other data types in Redis. Basically, the only limit here is the limit you place on the amount of time that you spend thinking about what you might want to build in a Redis module. So in summary, I told you I had a hammer. The hammer's name is Redis. and I applied it to many different nails. But I think at the end of this, you probably all agree with me. It actually is a suite of tools, or a Swiss Army knife, if you prefer that analogy. And it has that reputation for good reason. It's fast, it's lightweight, it's clustered. It has these sweet features that are purpose-built for a variety of use cases. It's extensible via modules. There really are so many possibilities. This is how I feel right now. This is how I felt when I started writing this talk too, for the record. So, anyway, thank you. And yeah, I think we do have time for questions if anybody's curious.
You mentioned you had spare memory. Does it mean you share Redis? You run Redis nodes on the boxes that run something else?
Yeah. So yes. Is the short answer. So we're running it on our web servers. So there's a Java application that's running that takes up a little over half of the RAM, and we're running physical machines. So it's like 32 gigs or 64 gigs, and there's some overhead that's left over there.
And they don't coexist CPU-wise.
Yeah, that was one of the things that made us really curious about Redis. I think we would have been able to do that with Memcached too. It's very low CPU overhead to read something from the cache and write it back, but we had no problems at all. I mean, I only watch the monitoring graphs. Ops tells me if we have problems, but it seems like no problems as far as I can tell. And we've been running it for like a little over a year.
All right, thank you, Robert. That was fantastic.
Thanks.